Good. Elimination part 2. I have two lines here, and I want to find out where they intersect. So I'm solving a system of two lines and finding where they intersect. Well, first of all, this isn't all arranged. The x's over the x's, the y's over the y's, and the numbers over the numbers. So let's just do it ourselves. This is fine. The first one, I like it. X, Y, equal sign, number sign. Well, this one I don't. I want this in the same order. So let's take equation 2, and let's play with this a little bit. I'm going to take the 2x, and I want to arrange it the same way as the first equation. So I'm going to take the 2x, and then y is next. So let me bring this. I'm making a little more room here. So next I want the y term. X, y equals number. Okay? So let's bring that over. Bring it over here, it's going to be a plus 2y. Okay? Then the equal sign. Got it? And the number. Good. So let's call this equation 1 now. And it's replaced that one. Same equation, just arranged a little differently. And then I'm going to take this other one, or somebody was saying, no, call it 2 is the second one. Okay, we'll call it 2. Whatever, doesn't matter. It's just so you keep track of them. Equation 1, x minus y equals 3. X minus y equals 3. Okay. Alright, now I want to look at coefficients and see that if I either subtract the equations or add the equations, I'm going to eliminate one variable, x or y. So I could multiply this one times a half. That's possible. Or I could multiply this one by 2. I really would like to do the first one by a half, just because that's kind of different. And I want to show you, think outside the box, try stuff. Don't say, ew, fractions, ew. Okay, I'm multiplying a half times equation 2. And that's going to give me half of 2, which is 1. Half of 2, which is 1. Half of 14, which is 7. And then I'll write equation 1. No, and don't worry, don't get all like, wait a minute. You've messed with this equation so much, it doesn't even look like the family it came from. So I once had this, and now I have, sure. You're just doing the same thing to both sides. You're either multiplying it by something or dividing it by something. Both sides at the same time. Moving stuff around, still the same equation. Okay, then I'm going to write equation 1 right below it as is. Okay? Now, look at this. Look at that. Add them up. I'll just put add. Usually if I change an equation like that, I rename it. I'll call it equation 3 or whatever. Who cares? Okay, add them up. The x's and the x's give me 2x. The y's give me no y's when I add them. Plus y and a minus y cancel each other out. And then a 7 and a 3 gives me 10. Okay, so I got 2x equals 10. Kabanga, kabanga. X equals 10 divided by 2, which is 5. Alright. Got a little line here so I can do a little more work here. I got x equals 5. Let's go back to equation 1. So now I have, instead of x minus y equals 3, I have 5 minus y equals 3. I'm going to switch places with the y to 3. Y comes over here. No, it's positive y. Thank you. 5 stays here. 3 comes over and it becomes a negative 3. Isn't that beautiful? Let's all join hands and sing. 5 minus 3 is 2. So what is our solution? We have x equals 5, y equals 2. My gosh, isn't that nothing short of a miracle? The magic and the mysteries of mathematics. Okay, so let's get rid of this and do one last, and then you're ready. You guys are ready to take on the assignment for all of solving systems unit. We can do it. So you're going to have to show me on the assignment. It will specify, I want you to solve this by graphing. I want you to solve this by substitution. I want you to solve this by elimination. In real life, once you get into grade 11, use anything you want. I gravitate towards substitution myself. But there are a lot of people that swear by elimination. Okay, here's my next system. System of two equations. This one says 3x plus 2y equals 2. And 4x plus 5y equals 12. Okay. First of all, is everything aligned up? Do we have everything in the right position? Are the x's above the x's? Are the y's above the y's? Are the equal signs above the equal signs? And are the numbers above the numbers? All looks good. Now, I don't have any matching coefficients. Look at the x coefficients. I got a 3 and a 4. I can't get rid of that. Y's, I got a 2 and a 5. So I want the coefficients for either the x, both x's, or both y's that are the same, or they're opposites, like one's 2 and the other's negative 2. One's 10, the other's negative 10, that sort of thing. So let me, well, what I can do is, in a situation like this, you have to multiply both equations times something. Different things. What I could do is, this is 3 and that's 4. What if I multiply this whole thing by 4? Then I'll get 12. And I'll multiply this whole thing by 3, then I'll get 12. Then I'll have identical x coefficients. So what I'm going to do is, I'm going to say multiply equation 1 times 4. 4 times 1. Can you see this? Let me look over here. Yeah, it should be visible. So 4 times 1, equation 1. That will give me 4. I'm going to write it. You notice that I was start to abbreviate a little. I skip a little steps here and there. You do that as you get comfortable. Don't skip too many steps. You will develop a sensitivity as to what steps to skip, because they're sort of tedious and obvious, versus skipping a step and leaving who's ever reading the solution kind of like in a state of wonderment, like, what did you do? Okay, so it's all fine. I'm multiplying both sides by the same number. It's fine. It doesn't change anything. 3 times 4 is 12x. 4 times 2y is 8y. 4 times 2 is 8. Okay. And now, let me put it over here. I'm going to call this equation 3. Okay? Now I'm going to multiply the second equation by 3 in order to get 12 for as a coefficient for x. So this is 3 times equation 2. Okay, so I'm saying 3 times 4x plus 5y, 3 times, just notice this thing shakes so much. Can you hear that? It's just, I've noticed that it's gonna be on my mind all the time. It'll bother me. Okay, 3 times 4x is 12x. 3 times 5y is 15y. 3 times 12 is 36. 36. Okay, and now look at that. I'm going to move it over and I'm going to call this equation 4, even though it's just really equation 2 all dressed up differently. 12x plus 15y equals 36. Now, since the x's match, I'll just subtract. Equation 3 minus equation 4. 3 minus 4. Okay, 12x minus 12x is nothing. 8y minus 15y is negative 7y. 8 minus 36. I hate subtracting. I've always hated subtracting, and then of all careers I choose to be a math teacher. Alright, 8 minus 36 is negative 28. I hate adding and subtracting. It's funny, when I was in university, do you know how many university math professors can't add or subtract? It's like you get a PhD, you learn all this math, and they got to make room for it in your brain, so they kick out stuff that you first learned. Get it, so they don't remember how to do it. This cancels. I get 4. Y equals 4. Look at that. Isn't that nice and clean? You don't always get clean answers. I want to do clean answers now because I don't want to have like a 45-minute video figuring out crazy fractions and stuff like that. But that's life. It happens. Y equals 4. So what's x? Sub in 1 or 2. Let's sub y equals 4 in equation 2. Okay? So 4 times x plus 5 times 4 equals 12. Alright, so 4x plus 20 equals 12. 4x plus 20 equals 12. 4x equals 12. Take away 20, which is negative 8. Divide both sides by 4. We've got negative 2. Sorry, I was sort of blocking everything there. So, our big solution to this, where does it cross? Negative 2, 4. You want to show that you have the right answer? You can substitute these coordinates into both equations and make sure the left side equals the right side in each case. That means it's on both equations. If it's on both lines, it's got to be the intersection point. Another thing you could do if you just want to satisfy yourself, when you're doing your assignment, if you get an answer and you're like, oh, I don't know if it's right or not, I don't know if it's right, go to Desmos. Go online to Desmos. You can enter both these and it'll put them up and you can see where it crosses. So, you're ready. You're ready. You're good to go. You're ready to take on, it's called S1, I believe, Systems 1. So the assignment, you can, and it's due tomorrow. Okay. Anyways, it's all posted. All posted, and I sent you an email. I want to make sure everybody gets the message. Okay? Stay safe. Don't have any problems. And tomorrow I'm having a class, so it is for extra help. All right. So drop by on a Google meeting. I'll post the thing just right when it starts. It starts the usual class time. Okay. So 10:50. All right.